Namaste children, this is Dr. GV here, your coach, and we're going to be doing Lightning 15. NEET stands for Illuminating Minds, from the doctor to the to-be doctor, that is you people. That basically we are going to be looking at rapid 15 questions which is going to come to you at lightning speed, illuminating your minds. Let's start with the first question. We'll start with the biology. Well, a dihedrid cross between two heterozygotes produce a phenotypic ratio of 9:3:3:1. Which principle of inheritance does this exemplify? This basically goes about the question which tells you about the different principles of inheritance. Is it law of segregation? Is it law of independent assortment, law of dominance, or law of linkage? So from the question itself, immediately the moment you see that there is a 9:3:3:1, you're going to go ahead and note that the answer is law of independent assortment. It is clearly the phenotypic ratio when two genes assort independently. It is due to law of independent assortment. So the moment you see this, you should know that it is independent assortment. Next question. Which of the following will occur immediately after the depolarization of the SA node? This is a very interesting question. There is a depolarization of the SA node. Immediately after that, what happens? Is it closure of the semilunar valves? Is it opening of the tricuspid valve? Is it contraction of both atria or relaxation of the ventricles? Put in the comment box what is the right answer. Quickly, just basically get 10 seconds to do that. After the depolarization of the SA node, what would happen immediately? Is it A, B, C, or D? What actually happens after depolarization of the SA node? You know that what is the SA node? That is your sinoatrial node. That is a pacemaker. So immediately after the depolarization starts, what wave will come first? The first wave is your P wave, right? After that comes your QRS wave. So therefore, the first wave is your P wave, and P wave signifies what? The contraction of both the atria. So immediately after depolarization of the SA node means contraction of the atria. If the same question was asked after the depolarization of the what node? What is the node? AV node. What would have happened? After the impulse reaches the AV node, then the depolarization will pass down to the Purkinje fibers and then to the ventricle. So therefore, after the depolarization of the AV node, the QRS would have begun. So that time it would have been the ventricular depolarization, and not the relaxation of the ventricles. The relaxation of the ventricles occurs after the depolarization of the ventricle. Then you get the S and the T wave, which basically represents the relaxation of both the atria and the ventricles. So after the SA node contraction, it is after the SA node depolarization, it is a contraction of the atria. It's a very important question that after contraction of the atria is what occurs after depolarization of the SA node, called the atrial systole, right? Good question. In a grassland ecosystem, the NPP is 500, okay? The respiration loss is 200. What is the GPP? The question here is about a simple formula that you need to remember. How many of you remember this formula? Put it in the comment section. What is the formula between NPP and GPP? Do you remember that offhand immediately? Very many children get confused in this. Confused agate. So we need to remember GPP ellide, NPP ellide anta. Remember this particular part, that the question here is basically he has given you the NPP and the respiration loss. Your formula is NPP is equal to GPP minus R. Okay, it is NPP is equal to GPP minus R. So therefore, what would be GPP? It would be NPP plus R is equal to GPP. So you want the GPP, so it is NPP plus R here. So add these two, the answer is 700. Perfect, simple. The technique that uses electric field to separate the DNA fragments according to the size. Which particular test is used to separate the DNA fragments? You know the DNA are what? Minus, negatively charged. So they will be moving towards basically the cation. So that means they are anionically charged. So therefore, there is one particular test which separates them. And how do they move? Based on their speed of their size. The one which is smaller moves faster and more further away, right? And so therefore that test is gel electrophoresis. You know PCR is an amplification test. Blotting is one of the techniques of PCR. Restriction mapping is the last part of PCR. So therefore it is only gel electrophoresis, right? So the smaller fragments move further under the electric field. Remember this point. Okay, we go to the fifth question of biology and then come to chemistry immediately after this question. Which organelle is known as the powerhouse of the cell because it has its own DNA and own ribosomes? It's a very simple question. It's a straightforward question. Most simplest question. The answer is mitochondria. You know that. Now, what is important is another question which I will come from this. Which of these organelles among the same organelle is known as endosymbiotic? Endosymbiotic. Okay, endosymbiotic. Which of these organelle is endosymbiotic? Okay, tell me. Mitochondria, lysosome, endoplasmic reticulum, or chloroplast? What do you think is the answer? Put it in the chat box. Which of them is endosymbiotic? This is not this question. This is another question which I'm asking. Please let me know which is endosymbiotic. The answer is mitochondria again. Why? Because it has its own DNA and ribosomes. That is what is the question here. Having their own DNA and ribosomes means they are endosymbiotic. So mitochondria is also endosymbiotic. This could be a very rare question which could be asked. Perfect. We go to some chemistry 5 questions next. The hybridization of the central atom in a PCl5 is in the shape of what molecule? You need to know this classical differences between the others, that is PCl3 and PCl5. What is the hybridization? The moment you know PCl5, you know that basically it has to have 5 carbon atoms attached to it. So phosphorus needs to undergo a hybridization. What will it be? It will form one with 3 chlorine here, and then it will form a 2 pyramidal structure here. So it becomes basically what? This is a trigonal. 1, 2, 3, trigonal. And these two become the 2 pyramids. So there are 2 pyramids here and 3 trigonal. So this is of the shape of a trigonal bipyramidal. And that will be a sp3d hybridization. The phosphorus undergoes 1s, 3p under d hybridization. Right? So that is what is coming here, a typical trigonal bipyramidal structure. The IUPAC name of cobalt NH3 taken 5 times Cl with a Cl2. How do you do this IUPAC name? Now the choices here are pentaamine chlorido cobalt 3 chloride, pentaamine cobalt 3 chloride, chloropentamine cobalt 2 chloride, or a pentaamine chlorido cobalt 2 chloride. So you need to basically see that there are two choices of each one of them. So how do you go about naming this IUPAC name? Put it in the chat box. What do you think is your answer? Is it A, B, C, or D? Let's look at it. Think fast. Think logically. I'm sure many of you will get this answer right. Okay, let's analyze this. So it is basically, you know here that NH3 is a ligand, Cl is a ligand, and the central atom has to be your cobalt. So your central atom is your cobalt, and around that you're going to have 5 NH3 and you're going to have 1 Cl. So therefore, the 5NH3 is going to give you a pentaamine and 1 Cl is going to give you a chloro. And they are attached to the cobalt. So they are pentaamine chlorido-cobalt. You always name the ligands first. So it is not a chloropentamine, it is pentaamine and a chloro which is attached to the cobalt. So therefore you say pentaamine chlorido-cobalt. Pentaamine chlorido-cobalt. So it is between these three. Now you know that the central atom is a cobalt. There is your Cl2, which is your anionic ligand. It has got 2. So that means the complex as such has a charge of 2 plus 2. NH3 is neutral. So therefore no charge. There is only one chlorine which will have -1. So therefore if the total charge should be +2, the cobalt should have a +3. So therefore cobalt here cannot have 2, cobalt has to have 3. Because the charge of cobalt here is 3, so therefore you say it is a pentaamine chlorido cobalt 3 chloride. It is not a 2 chloride. Right. So this is the way you analyze this. So therefore the co-oxidation state of cobalt or the cobalt oxidation state here is therefore +3. Right. So you try to identify what is your neutral ligand. You identify what is the ligand inside the sphere, what is its charge. You identify which of them is the counter ions, the anionic ligand, that is the counter ion. And so therefore what is the charge of that? And so based on this charge, you can know what is the charge on the complex. Once you know the charge on the complex, you can easily identify the cobalt's oxidation state, which is going to be +3. For the next question, N2 plus 3H2 gives you 2NH3. The delta H of this reaction is given as -92 kilojoules. Increasing the temperature will give you what? Will it give to increased yield of NH3, decreased yield of NH3? No effect on the equilibrium or increase the rate only. Now this question basically comes from which principle? How many of you can put that? Put it in the comment box. How many of you know that this is based on which principle? This is based on the correct Le Chatelier's principle. Le Chatelier's principle. And that, what does that state? If there is a factor which is increasing, the reaction will proceed towards that direction in order to counter the effect of that variable. So if the temperature is increasing, the direction of the reaction will go towards that side, which will lead to decrease in temperature. Now you know that this is an exothermic reaction, which means as NH3 is formed, the temperature is increasing. Right? Now, if you're going to increase the temperature of the reaction, what it means? Then the reaction will proceed towards that side, which will lead to decrease in temperature. Right? So if the forward reaction occurs, more and more NH3 is formed, the temperature will increase. You're already increasing the temperature reaction. So that means the reaction will now move towards that side, which will create a decrease in temperature. The decrease in temperature is towards the reactants. Right? So towards the products is increase in temperature, towards the reactants is decrease in temperature. Therefore, it is going to go towards the reactants, which means less NH3 is going to be formed. So it's going to decrease the yield of NH3. Hope you get this answer right. This is based on Le Chatelier. Simple. Need to analyze what is happening in the reaction. Good. The same thing is put here. Which carbocation is most stable? This is a very common question which is asked which basically brings you about the GOC, which talks about your GOC chapter, and that will basically be very important to note. How do you analyze this? Now, look at these and tell me which carbocation is more stable. How many of you can get this right? Actually, if you look at this question, this is a simple question. If you know that the benzyl radical is extremely most stable because it will bring in resonance, right? You know that the benzyl radical always undergoes resonance, and so therefore the benzyl radical here is going to give you the most stable carbocation. Another simple way of remembering that is that you need to go ahead and look at step by step what is happening. You know you have the methyl radical. The methyl radical consists of a single carbocation, and so because it is having a single plus, it is not having any electron donor. This particular one is the least stable. Correct? That is the least stable. Good. So carbocation methyl is the least stable. Then you look at the second one, CH3 2CH+. This becomes a secondary cation. Secondary carbocation. Secondary carbocations are more stable than the methyl, but not as stable as the tertiary. So there could be a tertiary which is more stable. So this is more stable than the first one. Next, CH2 double bond CH2. This is a tertiary carbocation, but what is happening? Here there is a double bond. Because of the presence of double bond between them, that double bond is going to create less ability for electron donation. Electron donation is decreased the moment there is a double bond. This therefore prevents CH2 double bond CH from allowing neutralization of the positive charge in the carbocation. Therefore, the one which is most stable is likely to be the benzyl radical. Remember, the moment you have the benzyl radical, the benzyl carbocation will have maximum resonance delocalization into the aromatic ring, and so that will have the maximum stability. So the order you need to remember is methyl is least, followed by secondary, then of course your tertiaries. Among them you have allyl is lesser than the benzyl. Benzyl is the one which is most stable because of resonance delocalization, right? Perfect. Next question. Which oxide of nitrogen is paramagnetic? This is another very common question which asks you different oxides and they confuse you with different things. The first thing you need to do here is to identify which is paramagnetic. How many of you know the principle behind this? Put it in the chat box. Put it in the comment box. How many of you know that it is, what is paramagnetic? Paramagnetic here basically, I'm used to, chat box because of the WhatsApp culture, So how many of you know this? Put it in the comment box. What is paramagnetic? Paramagnetic means what? The one which has lone pair of electrons. If it has lone pair of electrons, then it is likely to be more paramagnetic. Right. So you need to identify the one having the lone pair of electrons, which means it should have odd electron count. Odd electron count. Right? Simple logic. Odd electron count. So let's probably check here which of them has a odd electron count. Right? Simple. So let's start with your NO. N is 14, right? N is 14, you know that. And then O is how much? 8, right? Sorry, N is 7. You take the number of atoms, right? Not the molecule. It's not N2. It is N. So therefore it is 7 plus 8. So that gives you 15, right? So the first one is 15. It is a odd. It will have how many lone pair electrons? 1 lone pair, right? Good. So then comes N2O. N2O is N2, so which is therefore 14 plus 8. It obviously is 22. It is even. 0 lone pair, right? Then we go to the next one. NO2 minus. Now you know NO2. N is how much? 7. O2 is 16. 7 plus 16 is 23, right? It has got probably odd electrons. Similarly, it could have a one lone pair, but NO2 minus, there is one minus electron. So that means one electron is added to it, so which makes it 24. So this is 24, right? So the third one is 24, right? Third one is 24. We go to N2O5. What is N2O5? N2 is again 14O5. 8 5s are 40. So again you see here 54. So therefore it is again, let's come back. Sorry. So N2O5 is 54. So again, or even. So if you look at this, first here is without even drawing your structure, you come to know that only NO here is having lone pair, which is paramagnetic because it has an odd number of electrons. So this is the way you approach the question. First you find out between them how many electrons do each one of them have, and how many atoms does each one of them have. Based on that you can identify the number of lone pairs, right? Simple way to go ahead, and you know that that's an easy way to do it. Same thing here, odd number of electrons, and so therefore it is paramagnetic, right? Next question, quick. Fantastic. We have finished the 5 questions in chemistry. Our rapid fire for the physics starts here. Physics, we are going to go from the basics. So we're not going to go straight away to the 2025 NEET exam complicated physics questions. To do that, you need to know your basics right. So none of you play basically, I repeat, get your physics basics very right, get your formulas very right. You will be able to tackle even the difficult questions much easily, and ensure that you don't go wrong in your simple questions. So a projectile is fired at 37 degrees with a speed of 20 meters per second. What is the maximum height? This is a simple question. How many of you know this formula? Put it in the comment box. How many of you remember this formula for the maximum height? What is the formula for the maximum height? U square sine square theta by 2g, right? How do you remember this? Simple. If you want maximum height, you forget about the horizontal velocity. You think of the vertical velocity only. The vertical velocity is given by u sine theta. Square of that is u square sine square theta, and down you divide it by 2 times gravity, because the projectile is going up and coming down, and so therefore divided by 2g. Simple way to remember. You don't have to mug these formulas. If you get the logic right, you will remember the formulas. Height has to be related only to u sine theta, and u sine theta is basically going up, coming down. So u square sine square theta divided by g is twice 2g. Simple. So get the formula right, solve the question, you get your answer. Simple, very simple. U square sine square theta. You can also do this simply as, u sine theta the whole square. And what is u sine theta? U is 20 and your sine theta is sine of 37 degree. How many of you know what is sine 37 degree? Simple. Sine 30 degree is half, that is 0.5. So sine 37 degree should be 0.6. Just remember it is 0.6. Okay, so you get that as 12. So all you have to do is 12 squared divided by 2 into 10. Answer is 7.2. So the answer here closest is 8. So you put the closest answer. A wire of resistance 10 ohm is stretched 3 times its length. Its new resistance is. This is a common question that is given in different forms in terms of different, either changing the area, changing the volume. This is a simple question. Most of you know this. Very simple. What is the formula that you're going to use here? How is the resistance related to the length? How is it related? By what formula? The resistance is equal to what? Your R is equal to rho L by A, right? The resistivity into length by area. So you have 2 parameters here, length and area. You know, when you stretch a wire by 3 times, what is happening? The length will increase by 3 times, and what will happen to the area? Because the volume of the wire is going to be the same, the area is going to be divided by 3. So therefore, what is going to be the new resistance? Rho L into 3 divided by A by 3 is going to become 9 rho L by A. So 9 times the original resistance. So 9R. So if the original resistance is 10, the answer has to be 90. Simple way, right? The same thing here. We go to the next question. The work function of the metal is equal to 2 electron volts. The light lambda is equal to 400 nanometer falls on it. What is the maximum kinetic energy? Now this is a simple question. Sometimes we think too much, or we think very hard and we forget the basic equation that you need to use here. This is related to your work function, photodynamism, and so here you're going to look at what is the maximum kinetic energy. The formula for kinetic energy is, put it in the comment box. How many of you remember this formula? Ke is equal to E minus your phi, which is your work function. So the maximum kinetic energy is defined as the total energy minus the phi. What is the total energy? Has he given you the total energy here? You see that everything is put in electron volts. E is given by what equation? E is equal to what? You know it is equal to hc by lambda, right? And here, because it is electron volt, hc is converted into just 1240 by lambda in nanometer. If you know the lambda is given in nanometer, all you have to do is do 1240 by lambda. So this is the shortcut formula. You need to remember that whenever electron volt, everything is given in electron volt, your hc is just 1240 by lambda. You're going to get the answer straight away. So 1240 by lambda is going to give you 3.1 electron volt, and you know that the K max is equal to E minus 5. So that is 3.1 minus 5, because they have given you the work function is 2 electron volt, everything in electron volt again. So therefore it is 1.1 electron volt, which should be your answer, right? A. Next question. The object 15 centimeter from a concave mirror. This is a simple question which basically involves your optics, your formula for optics. 15 millimeter focal length is 10 centimeter. But what they have asked you, they have directly asked you the magnification. So you just need to use two formulas. You know the basic mirror formula, and then substitute it in that, get the value of V, and from that substitute into the magnification formula. The problem here is many of them get confused as to how to remember these formulas. One is a plus, the other one is a minus. You know there are two formulas. What is the formula for mirror and what is the formula for lens? How do you remember this? Remember this mnemonic, which I have very commonly told, LMP, right? LMNOP, right? So LM and then P in the same order. So remember this. Lens, L for lens. Lens is minus. Mirror, M stands for mirror, and that is plus. So lens is minus, mirror is plus. So in this equation, you know it is basically a mirror. So it's a concave mirror. So therefore, you're going to put the equation as plus. So the equation is going to be a plus, which means lens is minus and mirror is plus. So the equation is 1 by F is equal to 1 by V plus 1 by U. So when you solve this, remember here it's a concave mirror. Because it's a concave mirror, what is it? The mirror is more concave like this. Okay, and that is that is your coated surface, your reflective surface is inside. So your F is towards your left hand side. So F is also minus, negative. U is always negative. Important to remember the cardinal signs, in which direction they are going to be coming from. Object is going like this, so which means anything in this direction is positive, anything taken from here is negative. U is calculated from here, negative. F is calculated from here, negative. Both are negative. So F is negative, U is negative, your answer becomes minus 30, which means that the image is therefore formed here. And is it therefore inverted? It is therefore inverted. And what is the magnification? Magnification is minus V by U. So therefore the net magnification is also inverted. It is 30 by 15, which is 2. Simple. So that's how you get the answer. An isothermal expansion of an ideal gas. Now this is a simple question that is asked, but very confusing for many of them, because you forget the basis of the equation. What is it that is happening here in an isothermal expansion? Delta U is equal to 0, Q is equal to minus W. Delta U is equal to 0 or Q is equal to W. Looking at it itself, you can probably boil down the answer has to be between these two. Could delta U be greater than 0? Could delta U be lesser than 0? Now simple. What is delta U? It is your internal energy. What is it? Internal energy. Internal energy is directly a function of the temperature. Remember this, internal energy is just a function of your temperature. And so therefore, for an isothermal expansion, it is isothermal, temperature is constant, internal energy cannot change. So delta U has to be 0. If delta U is 0, what is then between the relation between delta Q and delta W? Remember, the basic equation that you need to know is, what is it? Delta Q, right, is equal to U plus W, right? Or you can write delta U is equal to Q minus W. And so therefore, if you know this basic equation, putting U as 0, you get Q is equal to W. So the answer is B, right? Q is equal to W. Perfect. We reached the end of this particular 15 questions. This was lightning questions to illuminate your minds. Do subscribe, like, and share our NEET channel with all your friends. I'm going to ensure that you people crack NEET like never before. And certainly we can do this all together. See you all.